My name is Indrani Das, and I'm an MD PhD student at Case Western Reserve University School of Medicine. And I received the 2026 PhRMA Foundation Predoctoral Fellowship in Translational Medicine. When I was 14, I got the opportunity to attend a magnet high school, the Bergen County Academies, where I was able to explore a lot of coursework in biomedical sciences, immunology, and a lot of advanced topics. And I was even able to pursue my own research project. And through the course of doing my own research and my own investigations into neurodegenerative diseases and immunology and neuroscience, I developed a love for the scientific process, as well as an understanding that in order to truly benefit patients of today and tomorrow, we need to be asking the hard questions on a molecular level and doing the research that enables us to make better cures for all these diseases we still don't have answers to. And this set me down the path of pursuing MD PhD training and devoting my life to combining science and medicine. A groundbreaking area of research for cancer therapy is CAR T therapy, chimeric antigen receptor T-cell therapy, where we take a patient's T-cells and we introduce a new protein onto the surface of the T-cell that binds to the cancer cells and ends up killing the cancer. And so CAR T therapy has led to more revolutions, especially for blood cancers. But these CAR T cells, they have a hard time getting into these solid cancers that are the most problematic for us to treat. My PhRMA Foundation funded research involves engineering these CAR T cells to secrete a peptide, a small sequence of amino acids in a circular form that has tumor penetrating properties. My engineered CAR T cells secrete this peptide that acts almost like a little grenade as it gets to the surface of the cancer, blowing open these dense tumor nodules to gain entry and access for the CAR T cells. And our goal is to use this tumor penetrating peptide in combination with novel CAR T therapy to have better outcomes in these solid and widespread cancers that currently we have no solutions for. A turning point in my research and career journey is when I competed in the 2017 Regeneron Science Talent Search. This is a competition that pushes high school seniors to synthesize their ideas into an original thesis, and eventually, when they reach the top 40, to defend their ideas in front of judges and seasoned scientists. This experience pushed me to explore my ideas and to defend my conclusions in a way that I never had before. And it gave me a chance to interface with some of the brightest young scientists of my generation, other people who are similarly motivated and passionate to pursue difficult problems. And this experience has stayed with me ever since, throughout college and into my MD PhD training. What I love most about research is that this isn't an ordinary science class where there is an answer at the back of a textbook. When you develop your own research question, first of all, it tends to be something very impactful, something that you believe will have an impact on others. And second of all, the ground is entirely yours. It's a sandbox, how you decide to design experiments to reach a conclusion and how you interpret the data you get and what becomes of that. I think one common misconception about science and scientists is that science is for certain people and scientists are someone special. Science is for everyone. Anyone can look into a question that they have, can develop their own ideas about it, and ask themselves hard questions, trying to pull apart their own thoughts and preconceptions. And that is what it means fundamentally to be a scientist and to engage with science. And so science isn't something that requires a fancy degree or a fancy institution. It's a way of life. It's a way of thinking and being. Outside of research, I really enjoy training mixed martial arts, including Thai kickboxing and jiu-jitsu. I also love lifting weights and exploring out in nature, whether it's hiking or kayaking. And I especially love doing these things and spending outside time with my family and friends. My big picture career goal is to become a surgeon scientist. I want to train in general surgery and then likely surgical oncology so that I can remove patients' tumors. And I also want to set up a translational science lab in this field where I can use my experience and what I gain as a surgeon in order to answer better questions about how to treat patients with tumors that have progressed beyond where we can cure it.